Hello friends, how are you? This is the second part of the truss. In the today's video, we will see about the various parts of the truss. What are the different types of the trusses? Video, we will also see how to identify zero force members. So let's get started.
Engineering Fundamentals Guidance by Somayya Sir, Pune, and I am Yugandhara Talele. Content of the videos are Introduction, Truss, its definition, what is statically determinate trusses, types of trusses, and do you know what are zero force member? What is a plain truss? Then we will solve problems based on the two methods. First is method of joints and the second is method of sections. Parts of trusses. I have made a video on how to read the drawing of trusses. It is under the title Contract Document and Detailing Process Part 2. In that video, I have discussed what are the parts of truss and how to read and identify members of the truss with their names, with their identification. Please watch those videos for better understanding. In this video, we will only see what are the parts of trusses that are important from mechanics point of view.
So, what are the different parts of the truss? Take this triangular truss. If the truss is like this, then these topmost element are called top chord elements, and these bottom elements are called bottom chord elements. And if there are elements in between, then these are called wave members.
So, in a truss, these top members are called top chord and these bottom members are bottom chord and these members are called wave. This is the span of the truss, distance from the support to support. It is span of the truss. And in this figure, this is a fink type of truss. And you can see here the part of the truss that is overhanging. This is a space truss. If the bracings are provided, these are provided like this. Top lateral bracings, sway bracings. In the subsequent videos, we will learn about bracings. Then these are the floor beams. This is the deck, that is the floor on which we walk. And stringer beams. So in this figure, you can see these supports are called heel joints. And these joints are called panel point. Then, do you know how to calculate the slope for the truss? It is the overall height of the truss divided by half of the span. Types of trusses. There are different types of trusses according to the arrangement of members. There are different types of roof trusses, different types of breech trusses. So this is the simple fink or W type of truss. See the shape of wave members. This is a Warren type of truss. Now, this is a hoe type of truss. This is a roof truss. And here, this is a hoe type of bridge truss. Now, you can remember it by remembering the shape of these wave members at center. It is forming M in roof trusses and it is forming W in bridge trusses. Now this is a Pratt truss and this is Pratt flat truss. So you can also remember it by the similar way. Now this is a Fink truss. Fink truss, see the shape of the wave members. This is Fink with cambered bottom chord and this is a Caesar truss which is used for roof. So these are some examples of truss in the practical life. Observe the surrounding and identify the types of trusses. Now we will see some important points about trusses. So notes. With typical bridge trusses supported at the ends and loaded downward at the joints, the upper chord are almost always in compression and end panels and lower chord are almost always in tension. So here I have tried to find the similar type of truss which is supported at ends and it is loaded downward by its self weight. So you can guess here the upper chord are in compression. Upper chord members are in compression and this end panel and bottom chord members are in tension. Now, note number 2. Truss members are axial members and forces on the truss joint are concurrent forces. What are concurrent forces? In the equilibrium video, we have seen what are concurrent forces and what are the equilibrium conditions for concurrent forces. So, concurrent forces are the forces that pass through the single point. So, for that equilibrium, we only need two equations. Summation of fx is equal to 0 and summation of fy is equal to 0.
So friends, now we will understand how to identify zero force members. So if two members are like this, these are collinear, connected like this. And if third member is perpendicular to them, did you got the arrangement? Two members are collinear and third is perpendicular to them. And there is no load on this joint. Then this third member has zero force. It is a zero force element. And now the second type of zero force members we will see. It is like this. The apex point. The truss is supported at these two supports. And If two elements are meeting at the apex and there is no joint load, then these two members are zero force members.
Now we will see what are zero force members. So these are the members. By visual inspection we can find out that the force in that member is zero. So how to identify it? See in this figure, if a third member connecting two collinear members carries no internal force unless there is a load applied at that joint. Did you get it? So these two are the collinear members. So if there is no joint load on this member, on this joint, then this third member, which is perpendicular to these two collinear members, is a zero force member. That is, the force in this member is zero. This is the second case of zero force member. Both members are forming an apex of the truss are zero force members unless there is a load applied at that apex. So these two members which are perpendicular to each other are zero force members. But if a joint load is applied at this joint, then it is not a zero force member. Thank you so much to you all for being with me throughout this video. Happy learning! I am grateful for your support. We will meet in the next video. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.